Welcome back. We're in lesson 2.6. This is the last lesson of chapter 2. We're going to talk about volume. In our previous lesson, we talked about area. Volume, let me back up. Area is like a sheet of paper, right? It's flat with two dimensions. Volume is more like a box. It has those two dimensions, but then it has more. Then it has a height. Whereas a sheet of paper just has a length and a width, a box has length, width, and height. Like, for instance, this Rubik's Cube. Before I showed you a picture of a chessboard, which had 8 by 8, so it had 64 square inches. This Rubik's Cube here, let's say that each one of these blocks is 1 inch, then that would be 3 by 3 by 3. So we would have 27 cubes, or 27 cubic inches. We can't say square inches because a square inch is going to be flat. This has a depth to it. So we have to now say cubic inches. And that's the definition of volume. Volume is the number of cubic units needed to fill the interior of a three-dimensional figure. And we use the exponent of 3 on the unit of measure to indicate volume. Now, the formula for the volume of a rectangular prism is length times width times height. And the volume of a cylinder is pi times r squared times height. Now, if you look closely, you'll see the area formula within that. So area is what? Area is length times width. And in a cylinder or in a circle, area is pi r squared. So that's this part right here for this area and this part right here for this area. So volume is just the area of the base, or the area of the main shape of the item, times the height. Once we multiply and add that height on there, you can see it here. Let me use my highlighter. Once we multiply by height, it turns into volume. So area of the base, that's a way we can relate all of volume together, whether it is a cylinder or a rectangular prism. It is always going to be the area of the base times the height. If I can spell height correctly. We'll just use your best guess on that. So area of the base times the height, that is going to be your volume formula, regardless of how you get there. I know you have to get to the area of the base differently with a cylinder than you do with a prism, or differently with a circle versus a rectangle. But once you get past area, it's the same. You just multiply it by the height. So find the area first and then multiply by height. So I just wanted to pull your attention to that for just a second. So there are some conversions that we need to look at that change the unit of measure. Whenever we have two dimensions with area, the unit of measure is going to be, like, let's say it's inches, it'd be inches squared, right? Well, whenever we go into volume, now it becomes cubed. So you have an exponent of 3 because you have 3 units of measure being multiplied against each other. So we have an exponent of 3. Same thing here. R times H. That's going to be 3 dimensions. So we have a unit of measure with an exponent of 3. Now, in the customary system, that's our U.S. standard system, when you have a cubic inch, that is 231 cubic inches, that's the same as 1 gallon. So we can actually use a unit of reference. 231 inches cubed is the same as 1 gallon. And notice gallon is not cubed because the gallon is already a volume measure. It's already volume, so we don't have to cube it. It's already cubed. Same thing in the metric system. We have 1 cubic centimeter is the same as 1 milliliter. So we don't have to cube milliliter because liter is already cubed. It's already a measure of capacity. So we can do customary to metric. We can swap those back and forth as well, from quarts to liters and liters to quarts. So let's jump in with both feet and do example problem 1. We're going to find the volume of a rectangular prism whose length is 6 centimeters, the width is 4 centimeters, and the height is 5 centimeters. Don't let that rectangular prism throw you off. It's just a box. Rectangular prism means that we have 6 parallel sides, 2 for each of the dimensions. So that means we have a top and a bottom, a front and a back, and a left and a right. That's our rectangular prism. And the top is the mirror image of the bottom. The left is the mirror image of the right, and the front is the mirror image of the back. So we have 6 sides, but there's only 3 dimensions that illustrate those sides. So in this rectangular prism, or in this box, we have 6 centimeters for the length. The length is always the longest measurement. The width is 4 centimeters. And the height is 5 centimeters. And height is usually determined by the lateral edge of the object, but when you have a rectangular prism, any one of its sides can be a lateral edge. Any one of its sides can be a depth. It doesn't matter because there's nothing wonky going on. There's no specific shape. It's all rectangles. So all we have to remember with a rectangular prism is that we need to find 3 unique dimensions and multiply them against each other. So the volume of a rectangular prism is going to equal, for this one, length times width times height, which would be 6 centimeters times 4 centimeters times 5 centimeters. And so that's going to be 6 times 4 is 24. And 24 times 5 is going to equal 120 centimeters. And we have 1, 2, 3 units of measure. So that's an exponent of 3. And that indicates volume. That exponent of 3 indicates cubic measure, which tells us that it is a volume. All right, so let's look at example 2. So in example 2, remember how a square was a special rectangle because all of the sides were the same length? A cube is the same thing, but with volume. All of the sides are going to be the same. So it is exactly, all the leading edges, all the lateral edges are going to be the same dimension. So this has 8 inches by 8 inches by 8 inches. So we really just need to cube the 8 and cube the inch. So we would say 8 times 8 times 8. That would be 8 cubed. Or actually the right way to do this would be the volume of a square equals the dimension of the side cubed. So that would equal 8 inches cubed. And 8 times 8 times 8 is 512. And then that is going to be inches cubed because we put this power on that unit of measure. And that would be the answer to that problem. Now, all you're really doing, you're doing the same thing you would for any rectangle. You're just saying 8 inches times 8 inches times 8 inches. That's exactly what you're doing when you do this. But because it's a cube, why write it 3 times if we don't have to, right? Remember, I've made it a point to say before that mathematicians are lazy. We are. So if we can take a shortcut, we write it with a shortcut. So example problem 3 is where it gets a little bit harder. Remember though that I told you that volume is really just the area of the base times the height. So the volume of a cylinder is going to be the area of the base times the height. So all we have to do is find the area of the base. And the area of the base, in this case, the base is a circle, right? So the area of the base is going to be a circle with a radius of 10 feet. So let's find the area of the circle first. So that is going to be pi times 10 feet times 10 feet. Now, we can use 3.14 for this, and most of the time that's going to be fine. But there are going to be times when the bigger the number, 3.14 is not going to round out to match exactly. So what I would like for you to do whenever you solve these types of problems that have pi, just use pi on the calculator if you have it. Okay. So I'm going to say pi times 10 feet times 10 feet. And that's going to give me 314.159. Now, I am not going to stop there. This is my area. Okay. I need to go on to volume, but I am going to just write this in. I'm going to round it to 2 decimal places. So equals 314.16. Now remember, if we had just used 3.14 for pi, we would just have 314. Right? So we would already be different by a little bit. So that's why I say the bigger the number, the more change there is. So when you have little numbers, using 3.14 is fine, but it's probably a better practice for you to be more accurate to use the pi symbol on your calculator if you have it. So now we're going to multiply this by 20 because we have the area of the base. This is the area of the base. So 314.16, and that's feet squared. The height is 20 feet tall. So we're going to multiply that times the height. And we'll see what that gets us. So let me get my calculator back up. All right, so I'm going to round this to 314.16 times 20 feet, and I get 6,283.2 as my answer. Let me double check that. Yes, that is the correct answer. 6,283.2, and that's going to be feet 2 times and a third time, so that's feet cubed. So that's the way you want to do the answer or do your problems. You want to use the pi button on the calculator because number 1 is fewer buttons to press. Number 2 is going to be more accurate. And number 3 is going to match the answer in the book, because the book is using, even though it told you to use 3.14 at the beginning of the area, it's actually using the pi symbol on the calculator. So use the pi symbol on the calculator and your answers will be checked correctly more often. However, if your answer is within just a few decimal points, I'm going to do the calculation manually and see if you use 3.14, and if you did, then I'll go ahead and give you credit for it. But just use the button on the calculator and you won't go wrong. I understand when like the calculator dies or you don't have access to a calculator and you have to do it by hand. Okay, I get that. So I'll allow for that opportunity, but it's a lot easier on both of us if you just go ahead and use the button on the calculator to make your life easier, and the system will then mark it correct. All right, so let's look at the next example problem. So example 4 is a conversion problem. It's getting us to use that volume capacity relationship that we had earlier. So we know that there is a relationship between cubic inches and gallons, and that looks like this. It's in your notebook, and it was in the notes on the first slide. 231 inches cubed is the same as 1 gallon. So if we have 845 inches cubed and we want to convert that to gallons, we're going to use this unit of reference. So all I have to do is write this as a fraction, 845 inches cubed. And inches cubed is what I want to cancel because I want to take it 2 gallons, right? So I'm going to put gallons in my numerator, 1 gallon, That's the unit of measure I want it to be. And I'm going to put 231 inches cubed in my denominator. So that allows me to cancel inches cubed as a unit of measure. So what I ended up with is 845 divided by 231. And whatever that unit of measure ends up being will be gallons. So I'm going to pull up my calculator and I'm just going to put that in. 845 divided by 231. And that gives me 3.6580. So I'm going to round this to 2 decimal places, and I will get 3.66 gallons. And that is the answer that I'd be looking for in the system. So let's look at one more like that. So now we're going to convert 400 cubic feet to gallons. So before we had inches to gallons, now we've got cubic feet to gallons. So fortunately, we have been given the unit of measure for feet as well. So 1 cubic foot is equal to 7.48 gallons. So that unit of reference is given to you. So we can use that to convert this into gallons. So 400 cubic feet, or feet cubed, however you want to say it. And I'm going to put cubic feet in the bottom in the denominator so it'll cancel. So 7.48 gallons goes in the top and 1 foot cubed goes in the denominator. So then these cancel. So now I just have to multiply 400 times 7.48. Simple enough. So 400 times 7.48 is equal to 2,992 gallons. Easy peasy, not so bad. So let's see, I think we have one more like this. So we're going to have to do a little bit of extra conversion on this problem. Our unit of reference tells us that 1 cubic centimeter is the same thing as 1 milliliter, but we want to go to liters. So we're going to convert from cubic centimeters to milliliters, and then from milliliters to liters. Now, if you remember your steps, you know that milli is a liter divided by 1,000. So that means there's 1,000 milliliters in 1 liter, right? So these are the units of reference that we're going to have to use to get to liters. So let's begin with 500 cubic centimeters, and we're going to turn that into milliliters. So that would be 1 milliliter on the top and 1 centimeter cubed, 1 cubic centimeter on the bottom. So we can cancel out cubic centimeters. Now we're going to go from milliliters to liters. So we want milliliters on the bottom and liters on the top. So 1,000 milliliters. So now we can do the math. 500 times 1 times 1, that's 500. And then 1 times 1 times 1,000, that's 1,000. And the milliliters canceled. I forgot to do that. So our unit of measure is liters. 500 divided by 1,000, that's going to equal 0.5 of a liter. So half a liter. So that one was not so hard. We just had to remember that we need to go from milliliters to liters. So don't forget about those little details. Remember to read the question to see what it is asking for to make sure you answer it fully. Those little things will trip you up. And that's all we have for lesson 2.6, and that's all we have for chapter 2. So study your material, make sure to look over your workbook and your notes, and we will have a quiz next. And I'll see you in chapter 3.